right, we're going to start this video with some definitions, and many of them you may know. A linear equation, of course, is an equation whose variables have an order with a maximum of 1. So we've got a single linear equation would be something like a1x1, a2x2 equals some constant. So highest order is 1. If we have a system, we have multiple equations. So I could say c1x1, c2x2 equals b2. So now this is a system. A solution can be a single point, or it could be a set of points that make our equations true. So x1, x2, x3, for as many variables as I have that make the equations true. A system is, let's start with consistent. A system is consistent if it has at least one solution. So consistent, at least one solution. So then inconsistent, you can guess, has no solutions. Homogeneous equations, a homogeneous system. Homogeneous has all of the constants are 0. In this case, x1, x2, all of our x's will also be 0, is one solution but may not be the only one. So there might be other solutions, but for sure the x is equal to 0 will be a solution. A system of equations is underspecified if I have less equations than I have variables. So let's say that my system goes down to m variables. So let me slide this over a little bit. So let's say that we have plus amxm, and then that would be cmxm, and then let's go down to bn. So if I have more variables than I have equations, my system is underspecified. If I have more equations than I have variables, then it's overspecified. Obviously, the sweet spot is when I have the same number of equations as I have variables. Any system that's underspecified, I'm always going to end up with general solutions. So I'm always going to have infinite solutions because there's no way of knowing exactly what all of the variables are in an underspecified situation. All right, we're going to look at some examples of this in our next examples.